aptitude, which is on numbers, right? So you see, when we talk about numbers, it has got a lot of areas or a lot of concepts, which is why I have broken these numbers into a few modules. So you can expect in this module we will discuss a few important concepts like classification of numbers, properties of even and odd numbers, properties of prime composite numbers, and also we will talk about rules for divisibility. And definitely we will do a lot of problem solving from all of these concepts, right? So um, let's start with the conceptual part to begin with. At first, when we classify the numbers, let us understand what all types of numbers are there. Definitely in your exams, we do not look at imaginary numbers. We are only talking about the real number part, right? Which is this part. So this is not going to come in your exam. So we can exclude this. Just to tell you about some typical definition of numbers, we call a number rational number when the number can be expressed in the form of p by q, where you see p and q are integers and q is not equal to 0. Similarly, we can have expressions of irrational numbers where we are taking square root of non-perfect squares. We are talking about irrational numbers. Then we have natural numbers, whole numbers, prime and composite numbers, right? Like prime numbers are those which are divisible by 1 and itself, otherwise it's a composite number. Then we have odd and even numbers. If the numbers are divisible by 2, then it is even, otherwise it's odd. Then we have recurring numbers, which are like, having the same digit coming up more than once and it is never ending. So that is reoccurring. So from that word reoccurring, we have this word called recurring number. And hence non-recurring numbers are those which will stop, unlike recurring numbers. Then we have proper fractions where you see the numerator is less than denominators. Definitely we have improper fractions also where the numerator is more than the denominators. And then we have mixed fraction, right? For example, a number like this will be called a mixed fraction, 2 and 3 by 5, right? So having said that, some diagrammatic representation of rational numbers where integers you see are a part of rational numbers. Within integers, again, you have negative numbers, 0 and positive numbers. So a part of that will be whole numbers. Starting from 0 to all the positive integers will be whole numbers. And only if I talk about positive integers, that is nothing but natural numbers, right? So that is what it looks like. Now, if I look at the properties of odd and even numbers, what happens when I add or subtract or multiply or divide? Definitely for division, there cannot be any specific rule because it is not known that after dividing two integers, whether you will get an integer or not. But certainly we have rules for addition, subtraction, and multiplication. So for example, when I do even plus even, I get an even number. When I do even minus even, I will get an even number. When I do even into even, I get an even number. That is what it says for the first row with examples. Similarly, if I do even plus odd, I get odd. I do even minus odd, I get odd. If I do even into or odd into even, I get even. That is what it describes in the second row. And in the third row, it is about operating on odd numbers, like odd plus odd gives you even, odd minus odd gives you even, odd into odd gives you odd, right? So that is what it says over here in the properties. So having said that, I think let us also consider the rules for divisibility. So how to check whether a number is divisible by certain numbers, like how to check whether a large number is divisible by 2 or 3 or 4, etc. So here, the only thing that is not much relevant for you is rule of 7. That is not something that they would ask probably in the exams. I have not seen much, but definitely the others are important. So you see, the rules are presented in front of you with example. For example, if you look at 2, we should look at only the unit digit, right? So the last digit should be 0 or an even number, then it is divisible by 2. Similarly, for 3, the sum of the digits should be divisible by 3. For 4, the number formed by the last 2 digits must be divisible by 4. For 5, the last digit has to be either 0 or 5. For 6, it has to be divisible by both 2 as well as 3. Only then I can say that it will be divisible by 6. Similarly, for 8, we should check the last 3 digits of the number. For 9, we should again, it is similar to rule of 3. The only thing is the sum of the digits should be divisible by 9 this time. Rule for 10, the last digit should be 0, right? So that is how it looks like. There is a special rule for divisibility by 11. So please understand this. I have taken an example to demonstrate the rule for divisibility by 11. So you take the alternate digits and add separately. I repeat, you take the alternate digits and add separately. If the difference of the sum is either 0 or a multiple of 11, then we say that the number is divisible by 11. So in this case, you can see 14 minus 14 is 0. So we will say that this number is divisible by 11. In case this difference instead of 0, if it is 11 or its multiple, even then we can say the number is divisible by 11, right? So that's a special rule for divisibility by 11. Correct? So having said that, let us get into some problem solving. So let me start with this question. To begin with, all of you, please get going. Please give it a try and do share your answers in the chat box. I will be discussing the solution shortly. But till then, let me see how many answers I get in the chat box. Please get going, all of you, and share your responses in the chat box. All right, so let me discuss this out, guys. So you see, at first, definitely we will look at the basic concept to crack this. See, if we know that average of 4 numbers is 12.25, we can always say that the sum of these numbers will be 49. That is 12.25 into 4. Now, if I look at these 4 numbers as P1, P2, P3 and P4, we know that sum is 49. Now, you see, in general, we know that most of the prime numbers are odd. Like if you look at 3, 5, 7, 11, 13, 23, these are all odd numbers, right? So in case we are adding 4 odd numbers, by the property of odd and even numbers, we know the addition of 4 odd numbers must be even. But then how come we have an odd number on the right hand side? So there is some contradiction somewhere, which means our assumption is not wrong that all the 4 numbers are odd. Or in other words, we can say out of these 4 numbers on the left hand side, one of them must be even. Now, what is the only even prime number? That is number 2. So, number 2 must be one of these. Alright, so your answer to this question will be 2. Right, so number 2 has to be one of these 4 numbers. I hope that was clear to you all. Alright, so we'll go ahead to the next one. Please try this and share your answers in the chat box. All right, very nice to see quite a few answers in the chat box. So let us go ahead and discuss this out. So this is definitely a recurring decimal. Let us understand a process which is called rationalization of recurring decimal. In fact, our answer lies in that process itself. Let us understand, if I multiply this number by 100, definitely the decimal point will shift 2 places to the right. And then if I subtract the original number from this, on the left hand side we will get 99 times of D. On the right hand side, please understand the entire part after the decimal point will cancel, and hence we will only have A1, A2. Then we can say D will take a value of A1, A2 divided by 99. Now what's the question? The question is, by what should I multiply this so that I get an integer value? You see, if I want to multiply it by something, I must cancel the 99 in the denominator, right? Now this method is called rationalization. Why? Because a rational number takes the form P by Q, where P and Q both are integers and Q is not equal to 0. You see, A1, A2 is an integer, 99 is of course an integer, so it gives you a rational form of the number. However, if I want to multiply this number D and make it an integer, then that multiplier must cancel 99 in the denominator. So that multiplier must be a multiple of 99, right? So the only option that will satisfy over here is 198, because that is double of 99, or in other words, it is definitely a multiple of 99, and hence that should be your answer, right? I hope that was clear to you all. All right, we'll go to the next one. In case you have any doubt, anyone having any doubt, please feel free to let me know. We'll be glad to, answer your query. And by the way, I was discussing with your, batchmates in the earlier class, in the second batch, basically, that I always feel that it is very, very important for everybody to be active on, networking. When I say networking, it is not only about social networking. I am talking about a serious professional networking. I am an alumni of various institutes, and my professional network has helped me tremendously, whether it is my, personal life or professional life. So I believe that you will also take that advantage of getting connected with huge number of people. You see, relationship is always an asset. So build a good relationship. I am very glad to already remain associated with some students via my connections. So I'm sharing my connections in case anyone is willing. Do get connected and explore the network professionally, so that you can get some advantage during the placement or after the placement also. It is a huge resource that is available to you already, which you should explore. And meanwhile, also try the question and share your answers in the chat box. I will be discussing the solution shortly. Till then, let me see if I can receive some answers. All right, so let me discuss this, guys. You see, if I look at one page of or rather one sheet of a book, then it will have two numbers. On one side, it will have even number. On the other side, it will have odd number. So when I take out 50 or 25 such consecutive sheets, in these 25 sheets, of course, there will be 25 pairs of numbers, and I can say there will be 25 even numbers and 25 odd numbers. 25 even numbers will add up to a number which has to be even by the property of even numbers. But 25 odd numbers, if you notice, you see, if you add 2 odd numbers, you get even. But if you add 3 odd numbers, you get odd. So what I mean to say is, if you add odd number of odd numbers, you always get odd number as a result. So at the end of the day, when you add the entire thing, you are adding an even number with an odd number. So the result has to be odd, right? So your answer will be odd. Very happy to see all the responses are correct. Very good going, guys. I hope that was clear to everybody. As I have been telling, in case of any doubt, please feel free to let me know so that I can clear your doubts. Right, so let us go ahead with the next one. All of you, please try this.
What did the friends did? Say, did come here and say us. given by 2 here, and what did the friends do? Read the other line.
Okay, can you please mute yourself if you have nothing to mention as such?
To talk to his friend and tell them the string he had seen.
All right, so let us understand this. Now, you see, we will use this basic property of algebra that a square plus 2ab plus b square is equal to a plus b whole square. So I have to ensure that the given expression takes the form, a square plus 2ab plus b square. So when it has to take the form a square, then the power has to be even. So then in that sense, 2 to the power 12 will become one such part which will look like a square. Now definitely 2 to the power 15 cannot be b square because 15 is an odd number. So 2 to the power 15 will be the part of 2ab. So if I have to match the powers, you see when I multiply, the powers get added, right? So you can see in the power in the middle, you see 1 plus 6 plus 8 will, give you 15. And then 2 to the power 8 whole square you have, which is 2 to the power 16. So this way we can compare and we can say that the value, so this becomes 2 to the power 6 plus 2 to the power 8 whole square, which becomes a perfect square, of course. And hence we can say that the value of n will be 16, right? So that will be our answer. Very glad to see correct answer from Nader. All right, so I think it is clear to everyone. I hope so. In case of any doubt, please feel free to let me know. Okay, so let us go ahead to the next one. All of you, please give it a try. All right, so let us see. Got a few responses so far. So let me discuss this. You see, I will show you a typical way to find out squares of numbers where the unit digit is 5. So let's take an example of 35 square. So at first you consider 5 square and then write 25 as the last two digits, and then consider the other digit, which is 3. So with 3 you take the next number, which is 4. So 3 into 4 gives you 12, and that 12 gets placed out here, and this 25 gets placed out here. So 1225 becomes square of 35. Now this method can be uniformly applied for any number where the unit digit is 5. Now understand, if a perfect square has 5 as the last digit, then the base value will also have a 5 in the unit digit. But in that case, the last two digits must be 25. So very clearly it can never be 35, right? So your answer will be always no. Glad to see correct answer from a few people. I hope it was clear to everyone. In case of any doubt, please feel free to let me know. Okay, I think we can go ahead to the next one. Please try this, all of you, and as usual, share your answers in the chat box. Okay, so got a few responses already. Good. So let us look at the way to solve this. You see, at first we will try to express 132 as a product of three numbers which are called co-prime. Now what is co-prime numbers? Let us understand. Co-prime numbers are set of those numbers where there is no common factor except 1. Of course, 1 is factor of all the numbers. So then these numbers are called co-prime or mutually prime or prime to each other. The moment you do that, then you can say that if a number is divisible by 3 as well as 4 as well as 11, then that number will be divisible by 132. Otherwise, it is not. For example, if it is not divisible by 3 or 4 or 11, at least one of them, then we can say that it will not be divisible by 132. For example, you can say in case of 462, it is not divisible by 4, and hence we can say that it will not be divisible by 132, right? So that way we can say that out of all these numbers, 264, 396, 792 and 6336, these are the four numbers which are divisible by 132. Hence your answer is option 1, which is 4, right? So here all the concepts that we have learned will be directly used, right? So let us look at the next one. All of you, please try this. So let me discuss this with you all. So you see, at first we will consider a number formed by all the 9 digits using exactly ones. You see, the position of the digits may change in terms of here and there, but definitely the sum of the digits will always be 45, which is always a multiple of 9. And hence we can definitely see that each of these numbers will be composite numbers, right? So none of these numbers will actually be prime. All right, so I think I need to help you on this. You see, at first, understand, if you look at a 3-digit number, definitely we should consider its unit digit, tens digit, and hundreds digit. The way we can write this number will be 100A plus 10B plus C. And similarly, if I reverse the digits, then this number will be written as CBA, then it will look like 100C plus 10B plus A. Now here they're talking about sum of these two. When I look at sum of these two numbers, on the right hand side, if you notice, I get 101 times of A plus C plus 20 times of B. Now with that, we are supposed to add something or subtract something maybe. So then we need to check according to the options. First option says that we need to add 2B. Now if I do that, definitely 101 is not divisible by 11, hence the entire portion is not divisible by 11. So that is one thing. Then we can go to the next one, next option, that is in that case we can look at the third option also in a random order. And now if I can look at the second option, interestingly, you see, if you look at this, we will have it divisible by 101, right? So then you can say that the second option itself will be our answer, because it will be divisible by 101 if I add 81 times of B, right, which is the middle digit. Right, so I think that was clear. So let us go ahead to the next one. All of you, please try this and share your response in the chat box. Okay, so got an answer from Jayashree. Let us see what could be a possible approach for this. You see, when one leaf is removed, then two numbers are being removed. One is k plus 1. So definitely the sum of these two numbers will be k plus 1, which is 2k plus 1, of course. And if I do not remove this leaf, then all the numbers starting from 1 to the last page of the last page number of the book will be added. So if the book is having n pages, then it will be n into n plus 1 by 2. So now, as per the sum, n into n plus 1 by 2 minus 2k plus 1 is equal to 1228. So then we'll try to possibly find the value of n from the given options. Like you see, if I look at 49, then the sum up to 49 from 1 is 1225, but it's not possible, you see, because 1225 is already smaller than 1228, so it's not possible definitely. Looking at the next option, so if 49 is not possible, of course any number lesser than that will also not be possible, because then the similar thing will appear. So 42 is also eliminated, so we are left with option 2 and option 4. Let's see option 2. If I add the numbers, I get 1775. If I subtract 2k plus 1, I get 1228. It's already possible, because you see, in that case, we can say that the sheet that was removed, that page numbers were 23 and 24, which sums up to 47, right? So this will be our answer. In fact, just to check 51, why 51 is not our answer, you see 98 cannot be expressed as k plus 1. So 51 is not possible. So our answer in this case will be, of course, 50, right? So that's the situation, which is option number 2. All right, so let us go ahead to the next one. Please try this, all of you. All right, so let us look at this. Of course, you see, we can definitely say that the relationship will be like this, where n1 and n2 are the numbers, and it's reverse that we are talking about. Interestingly, you see 32 and 23 are co-prime numbers. So when the numbers are co-prime, we can definitely say that any multiple of 23 will be the value of n1, and the corresponding multiple of 32 will be the value of n2, because that will always satisfy this way. So from that, we can directly look at the options without doing anything. We can say that 69 is a multiple of 23, right? Hence, that would be our answer for sure. So you don't have to do any other checking. You just have to look at the options from here, and you can conclude that your answer will be 69. Very nice to see. Many students got it correct. Good work. So we did not have to really check for one part of this sum, if you have noticed, right? Let us go ahead to the next one. All of you, please try this and share your answer in the chat box. You see, there are two things which are possible, where you have three things rather, where you have all the numbers equal to +1, or you can have all the numbers equal to -1, or you can have half of the numbers as +1 and half of the numbers as -1. But then we are talking about, understanding even number of -1s will make it +1, right? Only then it is visible. So here it says when it cannot be the sum of the digits. You see, we can have possibilities like if all the numbers are +1, then it is definitely possible to have the sum as 14. If I have a situation where you see 12 of the numbers are +1 and 2 numbers are -1, then we can have +10 or 10 as the sum, which is option 2. In the third case, we can say that if 10 numbers are +1 and the remaining 4 numbers are -1, then the sum of the digits will be 6. So your answer will be 0, because if you have to have 0, then there will be odd number of -1s. Now, if I multiply odd number of -1, that cannot give you +1, that will give you -1. So 0 can never be the sum of these integers, right? So your answer over here will be the number 0, which is given in option 4. Right, so your answer will be option 4 here. Hope that is clear to you all. All right, so we will look at the next sum now. I'm avoiding this one pretty direct, so we will look at the next sum. All of you, please try this and share your answer in the chat box. All right, got a couple of responses. Very well done. So let us understand, if I group these numbers into those parts which are already perfect square, you see, then we will be left with an 11 and a 6, which are not having its pair. So the moment I bring another 11 and another 6 and multiply, I will have a perfect square situation. So definitely that means the multiplier should have an 11 and a 6, which is 66, right? So definitely your answer will be 66, right? Very well done, both of you. Now let us look at the next number, next sum on numbers. Please try this, all of you, and share your answers in the chat box. All right, so let us look at this. See, first, if you look at the pattern of the numbers here, you see 9 square is 81, and look at the sum of the digits, it is 9, which can be written as 9 into 1. Again, if you look at 99 square, the value is 9801. If you look at the sum of the digits, that's 18, which can be written as 9 into 2. Interestingly, if you look at 999 square, it is 998001. I hope you can understand, one 9 is getting added in the front and 1 0 is being added at the middle. So that way you get 998001, and the sum of the digits, if you notice, is 27, which can be written as 9 into 3, and so on. So if that is the way it is, then we can definitely say that our answer will have 2000 lines, right? So our value of n squares, the sum of the digits in n square will be 9 times 2000, which is 18,000, which is given in option number 3. All right, I hope that was clear to everybody. Interesting sum, right? So let us look at the next one. All of you, please give it a try and share your answers in the chat box. All right, so let us look at this. You see what the pattern again will be for the numbers that look like 2 to the power n. If you recall the rules for divisibility, we know up to 8 for sure. For divisibility by 2, you check the last digit. You check for divisibility by 4, you check the last 2 digits. For divisibility by 8, you look at the last 3 digits. Similarly, for divisibility by 16, you would have to look at the last 4 digits. And for divisibility by 32, you would have to look at last 5 digits. So if that is the way it is, then definitely if I divide this number manual, the last 5 digits are 84950. So if I divide 84950 manually by 32, I will get 22 as the remainder. All right. So you see your answer to this question will be 22. All right. So that will be the answer to this question. I hope that was clear. So let us move on to the next sum. All of you, please try this. Rather, let me see if I can just discuss another one. Just wanted to do this. Yes. Please try this, all of you, and share your answer in the chat box. All right, so let us understand this question. You see, in the exam, you might get a question that looks big, but don't get scared by the size of it, because you never know, this question could be really very easy if you filter out the unnecessary or the redundant part. For example, all that matters over here is to filter out the necessary portion where it says that this number has to be coming up with a suffix and a prefix, which means there has to be a digit before that and a digit after that, such that the entire number formed thus will be divisible by 11 and 8. So if I just pick up from the options, you see the first option is 3 and 7. So if I put 7 over there, at the last, it won't be divisible by 8. Right? Because it is an odd number, 7 is an odd number, it cannot be divisible by 8. Similarly, if I put a 6 there, it will be divisible by 8. So there is a possibility that option 2 could be my answer. Just before confirming, I go on to the next one. 454 is not divisible by 8 from the third option, so that is not my answer. Similarly, 452 is not divisible by 8 either, so that cannot be my answer also, which means my answer has to be Option 2, which is 1 and 6. You see, we have tried to apply the method of elimination over here. So you see, in that process, we did not even have to check for divisibility by 11, right? So that is how you can get the answer to this question. I hope that is clear to you all. All right. Okay, so I think today we have been discussing a lot of areas in numbers, starting from basic property, classification, rules for divisibility, remainders, etc. Definitely, if you practice this kind of questions more and more, you will come close to your success in the aptitude exam, definitely in the section of numbers or maybe in the intersection of maths. First thing, as such, we are going to talk about factors. Now, what do we mean by factors? What is factor? Definitely, if I can take an example, probably it will be easier for you guys. Factor, let's say if I look at a number like 24, all the numbers that can divide 24 are factors of 24. Correct? All numbers which can divide 24 are factors of 24. So what are the numbers which can divide 24? 1, 2, 3, 4, 6, 8, 12, and 24. So the usual question is, what is the number of factors? So if I count 1, 2, 3, 4, 5, 6, 7, 8. So we can say that 24 will have 8 factors. Right, guys? So the number of factors of 24 will be 8. I don't think there is any doubt here. Now, very common, example, if I look at a prime number, how do we define prime number? A prime number is divisible only by 1 and itself, which means a prime number will always have 2 factors, right? 1 and itself. So any number which will have more than 2 factors will be composite in nature. But now, my example was very simple, 24. So the number of factors was very easily found by listing down its factors. But it's always not possible like this. Given that it's a big number, a large number, how will I find the number of factors? So let me look at 24. Let me do something which is called prime factorization, right, guys? Can I write 24 like this? Is it okay if I write 24 as 8 into 3, and 8 is nothing but 2 cube, and 3 can be written as 3 to the power 1? If I write it like this, then I bring this 3 down, I bring this 1 down, and then I add 1, and then I multiply. What do I get if I do that? I get 4 into 2, that means 8. Right, guys? This is how we should find number of factors. So if I can generalize how to find number of factors, I can probably erase this example, and I can look at a generic number n, which can be expressed as a to the power x into b to the power y into c to the power z, where a, b, c are prime. This is called prime factorization, right, guys? This is called prime factorization. Then how do I find the number of factors? I find the number of factors by writing x plus 1 multiplied by y plus 1 multiplied by z plus 1. That will give me the number of factors for n. This will be number of factors of n. Something very, very interesting. Tell me, guys, if this is n, what will be n square? What will be n square? A to the power 2x into b to the power 2y into c to the power 2z. if I ask you what will be the number of factors of n square, what will be the number of factors of n square? Same funda you apply, no? You write 2x plus 1, you write 2y plus 1, and you write 2z plus 1, all right? Now, what type of number is this 2x plus 1? I don't think you should have any doubt. This is an odd number, right? What about 2y plus 1? Another odd number. And what about 2z plus 1? Another odd number. Now, what is odd into odd into odd? That's an odd number, no? Something very interesting. We can conclude that any perfect square will always have odd number of factors, right? Any perfect square will always have odd number of factors. In that way, the reverse is also true, which means any number having odd number of factors must be a perfect square. Right, guys? So with that introduction, probably we can look at a few sums to begin with. Please try this out. Others, please respond on the chat box. Okay, Anuj also got an answer. Rajoshi got an answer too. Great effort, guys. Very good effort. Okay, all right. Let's understand. First of all, we are looking at a number n, where n gives me, a number which has 27 factors. Now the question is, how can we express 27? Of course, there are different ways to express. For example, we can write 27 as 27 into 1, or as 27 itself for that matter. We can express 27 as 9 into 3. We can express 27 as 3 into 3 into 3. The moment you look at these three situations, I can think of n as a to the power 26, which corresponds to this example, where for a number which looks like a to the power 26, the number of factors will be 27, no? That is 26 plus 1. Consider a number which looks like a to the power 8 into b, which corresponds to, a to the power 8 into b square, which corresponds to the second situation, where the number of factors will be 8 plus 1 into 2 plus 1. Look at the third situation, where I can express n as a square into b square into c square, which corresponds to this situation. Then the number of factors will be 3 into 3 into 3. Remember, the number of factor for, I repeat, the number of factor for an expression a to the power x into b to the power y will be x plus 1 into y plus 1. So we are working on that fundamental, no? Number of factors of a number will be x plus 1 into y plus 1. This will extend beyond a, b, c, d, etc. Or even if it is one factor a to the power x, one prime factor a to the power x, then it will be x plus 1 only. Now, given that, very interesting. What is the question, guys? The question is on the number of prime factors. Don't forget, what is the number of prime factors in this case? Only one, no? That is A. What is the number of prime factors in this case? 2. That is A and B. What is the number of factors in this case? 3. A, B and C.
Yeah.
So what is the highest number of prime factors? 3. And what is the lowest number of prime factors? 1. So what is the difference?
2.
That is your answer.
Oh.
Your answer to this question will be 2. it was little tricky. It was little tricky. I understand. It was little tricky.
So
Anuj, yes, Anuj, yes, you got it right. Anuj, of course, you got it right. But what about others? Did you guys understand the explanation?
once more.
See, I am talking about a fundamental where the number of factors of an expression, a number of factors of an expression which is given by this will be x plus 1 into y plus 1 into z plus 1. That gives you number of factors, right? Now, what is the question here? The question is, given that n has 27 factors, what is the minimum and maximum number of prime factors? When I say prime factors, please understand all these numbers A, B, C, these are prime. These are prime numbers. The question is, what is the maximum number of prime factors and what is the minimum number of prime factors? If I look at this expression to the power 26, this number will have 27 factors, no? Now here I have only one single prime factor, that is A. Also, I could have expressed this number as A square into B square into C square. Even then it would have 27 factors, that is 3 into 3 into 3. Now in that case, I'll have 3 prime factors, A, B, C. The question was, what is the difference between maximum and minimum number of prime factors? Hence, your answer to this question will be 2.
So,
is this understood, guys? This is clear to everyone?
Explain once more.
Hello?
Hello.
Yeah, is this understood? Is this clear to everyone?
Yes, sir.
Everybody, is this clear?
Sir, prime factor কোনটা x 2x plus 1 totalটা?
Now, prime factor is A, no?
Okay.
Or B, or C. These are prime factors. Prime number, prime number. If I am looking at prime number to the power something, ওই পাওয়ারটা তো প্রাইম নাম্বার নাও হতে পারে। বাট আরেকবার ফেরত যাচ্ছি, প্লিজ আন্ডারস্ট্যান্ড গাইস, দিস পার্ট ইজ ভেরি ভেরি ক্রিটিক্যাল। দিস নাম্বার A, this number B, this number C, these are prime number.
Yes, sir.
The question was, what is the maximum number of prime factors? What is the minimum number of prime factors? See, if A is a prime factor, A square will not be a prime factor, no?
Yes, sir.
A square will be composite number or A cube will be composite number. But A itself will be a prime factor, but B itself will be a prime factor, C itself will be a prime factor. The question is based on that fundamental. What is the minimum number of prime factor? What is the maximum number of prime factor? Got it, guys? কোন জায়গাটা অসুবিধা হচ্ছে শান্তন?
দেখো, এটা যে তুমি এক্সপ্লেন করলে না, এটা বুঝে গেছি যে 3 - 1 করলে 2 আসছে, ব্যাপারটা ঠিক ধরতে পারছি না।
3 - 1 করলে 2 আসছে মানে বুঝলাম না।
মানে তুমি যে ইকুয়েশনটা বুঝলে না, এই যে 27 into 1, 9 into 3, 3 into 3, 3 into 3, এই যে সিকোয়েন্সটা করলে যে অ্যানসারটা।
First of all, did you understand how to find number of factors? Did you understand how to find number of factors?
ওটাকে ভেঙে নিতে হবে ফ্যাক্টরটাকে।
Acha, can you guys tell me what will be the number of factors of 144? What will be the number of factors for 144?
Sir, 3.
What is the number of factors for 144?
Oh, okay.
Sir, 15.
Cano.
Sir, 2 to the power 4 into 3 square.
Very
About
good.
4 plus 1 into 3, 2 plus 1.
Very good. Very good. So this will be the number of factors, right?
Yes, sir.
So if I ask you what are the prime factors of 144?
2 and 3.
2 and 3. These are the prime factors of 144.
Hmm.
So how many prime factors does 144 have?
2.
144 has only 2 prime factors. 144 has only 2 prime factors, that is 2 and 3. Is that clear to everyone?
Yes, sir.
Oh, अच्छा,
Okay.
Yes, sir.
So shall we proceed to the next question?
yeah.
Yes.
Find the number of factors. Square. Number of factors.
Let me first assist you once. Think of all situations where a number can have 8 factors. Definitely, since they are talking about the least value, you will take least prime numbers to begin with, no?
Yes, sir.
You will not take large prime numbers like 11, 13 or 17. You will take smaller prime numbers like 2, 3, etc. Given that, find all possibilities for n where n can have 8 factors. Now very easy, দেখো একটা জিনিস বোঝ, 8 মানে কি? একটা হচ্ছে 8 itself, মানে a to the power 7 will have 8 factors, মানে 2 to the power 7. আবার 8 কে আরেকবার লেখা যায় 2 into 4, মানে a into b cube. Make sense, guys?
Yes, sir.
আচ্ছা, আবার 2 into 2 into 2, তার মানে a into b into c,
To see.
যেখানে a b c ডিনোট করছে তিনটে আলাদা প্রাইম ফ্যাক্টর। এইবারে তোদেরকে বুঝতে হবে what is the least value that n is taking. If you take consider all different possibilities, what will be the least value n can take? যদি ওই এক্সপ্রেশন just then n square will be easy, no?
Yes, sir.
n square মানে ভেক্টরে যদি a to the power x b to the power y থাকে তাহলে a to the power 2x আর b to the power 2y হয়ে যাবে n square এ, right? Please try this.
So 15.
আচ্ছা, আরো দেখি, একটু বাকিটা ট্রাই করো, লেটস সি and discuss this. If I start looking at n as a possibility where I have different type of factors, one possibility is, of course, n will look like 2 to the power 7, and please understand, I will start with the minimum of prime factor. 2 is the least prime factor because my goal is to minimize the value of the number n. Also, n can look like 2 cube into 3 to the power 1. N can look like 2 into 3 cube. What is the other possibility, guys? N can look like 2 into 3 into 5. I hope you all agree with me if I say in all these cases we have 8 factors, no?
Yes.
Now the question is, what is the least value of n? Out of all these numbers, what is the least value of n?
24.
Anyone?
24.
24.
2
Of course.
cube into 3.
Of course, this is the least value of n.
Yes.
And remember, they talked about the least value of n. No, in the question, look at the question, they're talking about least value of n. So we should go by this expression. If that is so, what is n square?
21.
2 to the power 6 into 3 square, no? Any doubt, guys?
No, sir.
So what is the number of factors of n square?
21.
7 into 3. That means 21. Clear, guys?
Yes, sir.
Yes, sir.
All of you?
No,
Yes, sir.
বুঝতে পারলাম। Hello?
Yes?
লাস্টের দিকটা একবার রিপিট করো না, এই যে 2
If
to the
n
power 6 into 3 to
if n is this, then what is n square? Square of this, no?
oh আচ্ছা
What is square of this? The powers will get doubled. Then the number will become 2 to the power 6 into 3 square. Then what will be the number of factors? 6 plus 1 into 3, 2 plus 1. What is 6 plus 1? That is 7. What is 2 plus 1? That is 3. What is 7 into 3? That is 21. Hence, n square will have 21 factors. Clear, guys?
Yes, sir.
All right.
স্যার ফার্স্ট এডটাই 2 টু দি পাওয়ার 7 কেন লিখেছিলেন?
আমাদের তো 8 ফ্যাক্টরস নিয়ে কথা। 2 to the power 7 এর কটা ফ্যাক্টর থাকবে?
8টা।
I was listing down all the possibilities for n. 2 to the power 7 is also a possibility, no? Where I would have 8 factors. বুঝতে পারলি? There is one fundamental understanding for all of you, the difference between multiples and factors. For example, if I write 12,000 as 30 into 400, now please understand, the moment I consider the factors of 400 like 1, 2, 4, 5, etc., it will go on up to 400 itself. Every time I multiply 30, it will become a multiple of 30, no? So the situation boils down to finding out the number of factors of 400, right? Because each factor of 400 will produce a multiple of 30 if I multiply that number by 30. So the question is, what is the number of factors of 400? What is 400? 400 is 2 to the power 4 into 5 square if you do factorization. If you factorize 400, it will look like 2 to the power 4 into 5 square, no? So what will be the number of factors? Which means these many multiples I'll have. Hence, my answer to this question will be 15. There will be 15 multiples of 30, which will be factors of 12,000. Is that clear to everyone? Yes, Shantan got the right answer already. What about others? Are we clear on this, guys? Please mention on the chat box. Please chat to everyone. Please do not chat to me privately. Please chat with everyone. All of you, please chat with everyone. Chat in the everyone mode and mention once again if you have understood. All of you guys, please chat with everyone and say if you have understood. Okay, Shantan from Hyderabad is having some issue understanding this. Shantan, I think you should be clear on the basics. We are saying that 12,000 is 30 into 400. So as many factors 400 has, those many multiples of 30 I'll be able to produce. It's equivalent to number of factors of 400. Every factor of 400, that is 1, 2, 4, 5, etc. up to 400 itself, will be multiplied by 30 and produce a multiple of 30 itself. And all those numbers, 30 into 1, 30 into 2, 30 into 4, 30 into 5, that way 30 into 400, all these numbers will be factors of 12,000. So the question is, how many factors will 400 have? So we are trying to find out the number of factors of 400. For finding the number of factors of 400, we are doing prime factorization. We are expressing 400 as 2 to the power 4 into 5 square. So the number of factors will be 4 plus 1, that is 5. 2 plus 1, that is 3. That means 5 into 3, that is 15. About unit digit. Now what is so special about it? Definitely they ask questions like, 3, 5, 4, 7 to the power 2, 3, 7, 9, and they can ask you what is the unit digit of this number. Now when I want to understand the fundamental, please be clear on this part. If I look at a number to the power x and we are trying to find the unit digit, the value of the unit digit depends on the value of the unit digit of the base. All the remaining numbers are not important. These are redundant. When I'm trying to find out the unit digit, all I have to check is the unit digit of the base. Now the question is, what are the values that this unit digit can take? Definitely it can take any values. Depending on that, our answer can be found very, very easily. Now what are the values that this unit digit can take? It can take a value of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Now what are the situations which are possible? What are the situations which are possible? Oh, I'm so sorry. Please understand, if I look at this particular case, Please write it down. I'm going to explain. Now, what are the situations? First of all, put a 0 here. Doesn't matter whichever power you raise, your unit digit will be 0. Put a 1 here. Doesn't matter whichever power you raise, the unit digit will be 1. Put a 5 here. Doesn't matter whichever power you raise, your unit digit will be 5. Put a 6 here. Doesn't matter whichever power you raise, the unit digit will be 6. So what are we saying? We are saying if this is 0, then this will be 0. If this is 1, this will be 1. If this is 5, then this will be 5. If this is 6, then this will be 6. Which means 0 refers to 0, 1 refers to 1, 5 refers to 5, 6 refers to 6. So which is why I'm writing same. Now coming to 4 and 9. What about 4 and 9? Look at 4 and especially the powers. 4 to the power 1 is 4. 4 to the power 2 will give you an unit digit of 6. 4 to the power 2 is 16. That means it will give you a unit digit of 6. 4 cube is 64. So unit digit will be 4. 4 to the power 4, 256 will give you a unit digit of 6. So it will go on this way. 4, 6, 4, 6. So it will toggle between 4 and 6. Hence, I can say every odd power of 4 will end by 4 and every even power of 4 will end by 6. Which is why I have written even and odd. Same rule applies for 9. If I look at 9, the numbers will be 9, 1, 9, 1, 9, 1 that way. Which means every odd power of 9 will give you an unit digit of 9 and every even power of 9 will give you unit digit of 1. What about 2? 2 to the power 1, 2 square, 2 cube, 2 to the power 4. Remember, I am writing only unit digit. 2 to the power 1, 2 square, 2 cube, 2 to the power 4. 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8. Which means every fourth power of 2 will come back and give you the same unit digit. The same funda applies for 3, 7 and 8. The only thing is the value will change. For example, if it is 3, what are the numbers that will come? 3, 9, 7, 1. 3, 9, 7, 1. That way. Same thing will apply for 7 and 8. As I said, only the value will change. For example, if it's 7, it will be 7, 9, 3, 1. 7, 9, 3, 1. These 4 unit digits will come back. So, let me give you an example. If somebody asks you what will be the unit digit of a number like 512 to the power 359, you will firstly say, hey, all that matters to me is the unit digit of the base. So I'm better off finding unit digit of 2 to the power 359. And I'm going to check the power and I'm going to divide this power by 4 because it will maintain a cyclicity of 4 and I will find the remainder. Remember, I talked about the rules for remainder in the last class of numbers where I said for 4, all that matters is the last 2 digits, which means I should only check for 2 to the power 59 because I am dividing the power by 4 and for power and for divisibility of 4, the rule was check the last 2 digits. Now, if I divide 59 by 4, the remainder is 3, which means my answer will be 8 because 2 to the power 3 will give me an unit digit of 8. You understand the flow? First of all, I said the base value unit digit matters. So only 2 will matter. And in the power, since I'm checking for cyclicity of 4, I will divide this power by 4 and find the remainder. And for dividing by 4, I should check for last 2 digits, which is 59. When I divide 59 by 4, the remainder is 3. Hence, 2 cube will give me 8 as an answer. For this entire number, the unit digit will be 8. So this is the same step that you will follow for any question. Now, can one of you tell me the answer to this question? What will be the answer? Very good, Rajoshi, very good. So I'm only looking at 7 to the power 79, which will be basically 7 cube. And 7 cube will give me unit digit of 3. Because 7 will also maintain a cyclicity of 4. That's why I was checking by dividing this number by 4. Hence, I looked at only last 2 digits. Please try. Okay, we already got an answer from Rajoshi plus, but please hold on till others attempt. Guys, what is 5 factorial? I'm so sorry to change the color. What is 5 factorial? 1 into 2 into 3 into 4 into 5. Yes, of course, we all know this is 5 factorial. Now in 5 factorial, we have a 2 and we have a 5. Right, guys? So when I multiply 2 and 5, no doubt it will give me a 0 in the units place, no? What about 6 factorial? 1 into 2 into 3 into 4 into 5 into 6. It will also have a 2 and a 5, hence it will also give me a unit digit 0. So can we not say from all these numbers up to 100 factorial, for all such numbers the unit digit will be 0? I repeat, from 5 factorial onwards up to 100 factorial, for all such numbers the unit digit will be 0. Any doubt on this, guys? Now, the question is, what about 1 factorial, 2 factorial, 3 factorial, and 4 factorial? Of course, 1 factorial will give you unit digit of 1, 2 factorial will give you unit digit of 2, 3 factorial will, what is 3 factorial? That is 6, no? What is 4 factorial? That is 24. So, unit digit will be 4. Now, when you add 6 and 4, it gives you unit digit of 0 because 6 plus 4 is 10. So all that matters to me is the unit digit of 1 and 2, that is 3. Hence, my answer to this question will be 3. So the numbers which are important are 1 factorial, 2 factorial, 3 factorial, and 4 factorial. Because all the succeeding numbers will keep on giving you unit digit as 0. Are we all clear on this, guys? Yes? Great. We already got the correct answer from, I think, all of you guys. Cool. Chalo. Let's look at the next one. Another easy stuff. Let's try this. All right, we got many views, many different type of answers. Let's see. Acha, what is this number? Let's, if I look at this number as two parts, I am splitting it into two parts. One part will be 3 to the power 2720, and the other part will be 10 to the power 2720, right? Which means there is no doubt that this entire part will produce a lot of zeros at the end. Which means all that matters to me is the unit digit of this number, no? So that will be my answer. Remember, the question is, what is the rightmost non-zero digit? What is the rightmost non-zero digit? So after covering all the zeros from the right end, what is the first non-zero digit that you come across? Which is same as the unit digit of 3 power 2720. What is that? That is same as, remember, 3 maintains a cyclicity of 4. No, if you go back to the basics, 3 maintains a cyclicity of 4. Which means I should check for the unit digit of 3 to the power 4. 3 to the power 4 will have the same unit digit as 3 to the power 8, which will have the same unit digit of 3 to the power 20, which will have the same unit digit as 3 to the power 2720. That will be 1. Hence, my answer to this question will be number 1. Is that clear, guys? We already got a couple of corrections from Shayantan, Anuj, Rajorshi already gave a correct answer. Great, guys. Okay, cool. Very good. Very good. Chalo. Next one, guys, although, as such, we do not come across many questions on last 2 digits. And we were also discussing about unit digit particularly, but I just thought if I can look at one question about last 2 digits, if you could try without any formula or theory, whatever we have discussed so far, let's see who gives me an answer fastest. All right, we got one answer already. And oh, we got two answers from, we got three answers in fact. Okay, very good guys, very good, very good. Okay, we got answer from all four of you. That's phenomenal. That's very, very good guys. I'm really impressed. Okay, let's see. Was little tricky although, but I think if you apply logic, it will seem to be easy. Okay, let me cut it out from here. We have one more number, that is 129. All right. Okay, what is the easiest? First of all, if I'm finding the last two digits, I may jolly well exclude the third digit. It's not important for me because I'm only looking at last two digits of the final product. Which number out of all these will help me to narrow down the possibilities? Of course, 25. Consider any multiple of 25. What are the possibilities of last two digits? 25, 50, 75 and 00. These are the possibilities, no? Now, the moment you look at this number, along with 25, it gives you an even multiple of 25. What do I mean by that? Even multiple of 25. That means it's a multiple of 50, no? Even multiple of 25 is equivalent to a multiple of 50, which means I only have two cases, 50 or 00. Remember, it is multiple of 50 finally. Since it's multiple of 50, there are two cases, 50 and 00. Look at the other numbers. All these numbers are odd numbers. All these numbers are odd and hence the product is odd. So all I have is 50 into an odd number. 50 multiplied by an odd number will give you the product as 50 only. In terms of the last two digits, consider 15 to 7, 15 to 3, 15 to 9, 15 to 11, whatsoever. No doubt that the last two digits will always be 50. Is that clear, guys? Number of zeros at the end of n factorial. What are we saying? Let's take an example. Let me say, if I look at 10 factorial, I'm trying to find the number of 2's in 10 factorial. I'm trying to find the number of 2's. How many 2's will 10 factorial have? What is the number of 2's? So I'm writing 10 factorial as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. What about the number of 2's? Of course, we can count. We have a 2 here. We have so 1, and we have two 2's here. We have another 2 here. We have 3 2's here. We have one more 2 here. So what is the number of 2's? 1 plus 2 plus 1 plus 3 plus 1. So what is the number of 2's in 10 factorial? 1 plus 2, 3 plus 1, 4 plus 3, 7 plus 1, 8. Which means if I factorize 10 factorial, it will have 2 to the power 8 into something. That is the fundamental, you know. Similarly, if I want you to count number of 5's in 10 factorial, the number of 5's very clearly visible. See, this is 1 5. I have another 5 here, which means I'll have a 5 square in 10 factorial. So if I ask you what is the number of zeros at the end of 10 factorial, how does number of zeros occur at the end of a number? The number of zeros will occur only when I have tens. Only when I have tens. Now, how do I have 10? 10 is basically 2 into 5. So every time I have a pair of 2 and a 5, I'll produce a 10, and that 10 will produce 1 0. So every 2 and 5 as a pair will produce a 0 at the end of n factorial. So if I look at 10 factorial, all that matters is how many pairs of 2's and 5's I have. Please understand, although I have 8 2's, but I have only 2 5's. Which means These two 5s will pair up with two 2s and will give me two zeros. So what matters is number of 5s, no? Number of 10s will be same as number of 5s, and number of zeros will be same as number of 10s. So in a way, number of zeros at the end of n factorial will be same as number of 5s. Having said that, 10 factorial was very, very easy to find out because we could list it down, or we could explain, or we could elaborate. But what about a large number? If I take a large number, then how do I find? So by now you should be clear that number of zeros at the end of n factorial is equivalent to number of 5s in that number. Now how to find number of 5s? How to find number of 5s within a number? That has a specific process. Let's say someone asks you, what is the number of zeros at the end of 100 factorial? I repeat, what is the number of zeros at the end of 100 factorial? All you do is start dividing 100 by 5, one after the other. This is called successive division. You keep on doing that till you can, and forget the remainder. So for example, if I want to find number of zeros at the end of 150 factorial, I will say 150 divided by 5 gives me 30. When I divide that by 5, it gives me 6. I can divide it by 5, it gives me 1. So I can keep on doing that till I can and ignore the remainder every time. Please consider the quotient. Now all you do is to add the quotients. Add the quotients, which means at the end of 100 factorial, you will have 24 zeros. And at the end of 150 factorials, you will have 37 zeros. This is called successive division. Divide the number successively by 5 till you can. Right, guys? So, can you tell me what is the number of zeros at the end of let's say 178 factorial, or let me change it to 378. Let's say, what is the number of zeros at the end of 378 factorial? How will I find the number of zeros at the end of 378 factorials? So what will I do? I'll divide this by 5, no? And then I'll add the quotients. Hence my answer will be 93. So when you know that m factorial has, oh great, Shantan gave me an answer already, an absolutely correct answer, Shantan, great effort. So when you know m factorial has got n zeros at the end, that means if I divide m factorial successively by 5, the addition of the quotients will be n. What about the number of zeros at the end of 5m factorial? Then I would have I would divide 5m by 5, no? The first time I divide, I'll get m. Then I divide it I'll get the same stuff as the last case. And I already know the addition of all these will be n. But in this case, this m itself is another quotient, which means my answer will be capital M plus small n. Right, guys? So my answer will be capital M plus small n. That will be the number of zeros at the end of 5m factorial. Is that clear, guys? All of you? Please respond on the chat box. Okay. Cool. Let's look at the next one. There is something very, very interesting. Achha, by the way, I am helping you because I already explained you this. 100 factorial has 24 zeros at the end of it. So that's a clue that you can start with. For example, if 100 factorial has 24 zeros at the end, what about 101 factorial? Don't you think that will also have 24 zeros at the end? Because 101 does not bring any new 5. 101 factorial is basically 101 into 100 factorial, correct? So this number 101 does not bring any new 5. Hence the number of zeros will be same as what he had in 100 factorial. Right, guys? Hence, I can say that from 100 factorial up to 104 factorial, I'll have 24 zeros. Because I will not find any new 5 up to 104. The moment I have 105, I'll bring a 5, no? That will continue up to 109, where in each of these numbers, I'll have 25 zeros. And then from 110 factorial up to 114 factorial, one more zero will add. Then from 115 factorial up to 119 factorial, I'll have 27 zeros. So the range of n, that is the answer to my question, will be 115 to 119. Remember, they are talking about range, which means you have to specify the minimum and the maximum of the numbers. So the minimum possibility is 115 and the maximum possibility is 119. Right? By the way, something very interesting. Although I got an answer, this is my answer. Now I'm extending this 120 factorial up to 124 factorial. The number of zeros will be 28, no? Can someone tell me what will be the number of zeros at the end of 125 factorial? Guys, what about number of zeros at the end of 125 factorial? It will be 31. Why? Please understand, in 124 factorial, I have 28 zeros. Look at this number 125 factorial. I have additional number which is 125, which itself is 5 cube. Which means it gives me 3 more 5s. The moment I get 3 more 5s, of course, I'll have too many zeros. Too many 2s. I'll have much more number of 2s than number of 5s. So these 3 more 5s will bring me 3 more zeros, no? Along with 3 more 2s, of course. Hence, the number of zeros at the end of 125 factorial will be 31. So if anyone ever tells you that there is a number n factorial having 29 zeros at the end or 30 zeros at the end, you will tell him, sir, hey, please stop. We do not have any such number under the sun. There is no number which looks like n factorial which will have 29 or 30 zeros at the end. Right, guys? And you have the reason in front of you. Is that clear to all of you? Guys, please respond if it's clear. All right. All right. All right. by now you must have realized that the number of zeros is equivalent to finding number of fives. The number of zeros is equivalent to finding number of fives. So wherever you find a five, the only situation is, if you follow this pattern, the only situation is in the number that is 25 to the power 26. That will be little tricky. Now here I have 6 fives. Here I'll have 11 fives. Here I'll have 16 fives. Here I'll have 21 fives. But here, please understand, 25 itself is 5 square. Hence, I'll have 52 fives, no? So what is the total number of fives? I'll add all the powers. I'll add. If I add all the powers, I'll get the answer. So what is my answer, guys? What is my answer? 6 plus 11 plus 16 plus 21 plus 52. Yes, of course, it will be. Yes, absolutely. Guys, you got it correct. Our answer will be 106. That will be the total number of zeros at the end of this product.